Okay, let us discuss about the fragmentation. So here the maximum transmission unit, that is NTU for IPv6 network, must be at least 1280 bytes. In turn, maximum transmission unit defines the size of the largest protocol data unit that can be passed. For 802.15.4, maximum bytes is 127. The problem because of IPv6 with the much larger MTU is carried inside the 802.15.4 frame with the much smaller one. To remedy this situation, larger IPv6 packets must be fragmented in multiples in 802.15.4 frames at layer 2. The fragment header utilized by 6 low power PAN is composed of 3 primary fields. You can see in the right side of the picture, where it will be getting the fragmentation header, that is 6 low power double PAN fragmentation header, which is consisting of, first is header, and is the fragmentation header is there with 1 byte. There's a datagram size is there with 1 byte. Next is datagram tag is there with 2 bytes. And next is datagram offset is there for 1 byte. As the frame counts, it's going to be next. The fragment header utilized by 6 low power PAN WPAN is composed of 3 primary fields, and is datagram size, which is a 1 byte field, specifies the total size of the unfragmented payload. Then a datagram tag identifies the set of fragments for a payload. How many are there? So like that. Then datagram offset field delineates how far into a payload a particular fragment occurs. So it is a prediction that or time that it is offset, that it is going to be fragments are going to occur, that it is going to have the offset. So all 3 together it is going to have 5 bytes of data. Now the 6 low power PAN fragmentation header field itself uses a unique, that is a single byte bit value to identify that the subsequent fields behind it are fragmented fields, as opposed to another capability such as header compression. In the first fragment, the datagram offset field is not present because it would simply be set to 0. This results in the first fragmentation header for an IPv6 payload being only 4 bytes of long. This is a mesh addressing, where the header for the mesh addressing for 6 low power wireless PAN is shown over here. This header is there. Then we have 6 low power PAN mesh addressing header, including hop count. Let us see what is hop count and all. Then we have a source address is there, the 2 bytes, and destination address is there with the 2 bytes. Let us see that what is this mesh addressing. The purpose of 6 low power wireless PAN mesh addressing function is to forward packets for multiple hops. The 3 fields are defined for this purpose. First is hop limit. The hop limit for mesh addressing also provides an upper limit on how many times the frame can be forwarded. Each hop decrements this value by 1 as it is forwarded. Once the value hits 0, it is dropped and no longer forwarded. So it means to say that the destination has been reached. Source address and destination addresses are going to be present for the data to be reached. The source address and destination address fields for mesh addressing shown in the figure gets the endpoints of an IP hop. For the mesh, we have mesh under versus mesh over routings. IEEE 802.15.4 and IEEE 1901.2a that support mesh topologies and operate at the physical and data link layers. Two main options exist for establishing reachability and forwarding packets. So here what happens basically is we'll be going to use mesh under as well as mesh over routing packets. When we use mesh under, the routing packets is handled at the 6 low power WPAN adaptation layer. When we use this over or mesh over or route over, here we utilize IP routing for getting packets to their destination. A simple difference is that when we use mesh under, the time we use adaptation layer. When we use mesh over or route over, we use IP routing for getting packets their destination. What is this mesh under routing? Here the routing of IP packets, the 6 low power PAN mesh addressing header to route and forward packets at the link layer. The term mesh under is used because multiple link layers hops can be used to complete a single IP hop. Nodes have a layer 2 forwarding table that they consult to route the packets to their final destination within the mesh. So here we will be going to have the layers is going to have tables, which is going to be a start and the end. So in between that, any layers are going to be there, then the hops, so that it is going to have it, so that it can reach the destination in the proper route. An edge gateway terminates the mesh under domain. Here, the edge gateway must also implement a mechanism to translate between the configured layer 2 protocol and any IP routing mechanism implemented down there on other layer 3 IP interfaces. IP over route over scenarios. So IP layer 3 routing is utilized for computing reachability and then getting packets forwarded to their destination, either inside or outside the mesh domain. Very important thing. So all these things we are using to reach from the source to the destination. How many packets are going to reach? So we are having the source address also is there, that destination is address is also there. So using the IP, how that is getting routed. So when we have more than one hop counter, that's multiple hop counters will be present, then we should have proper routing table so that it is going to be reached in the proper manner. Each full functioning node acts as an IP router. This is a very important thing. The full functioning nodes are going to act as IP router so that each link layer hop is an IP hop. When a low